All right, so I'm gonna put up here kind of our basic thing that we're gonna need for today. Our BPA log base B of A equals P. This guy, our BPA log BAP. We're gonna use this for all three of these things up here. So look at this for a second and see if that helps you figure out what the heck's going on here and what we can do from here. Dude. Look, the plug over here. Guys, there's a plug with a table right here so that the cords don't have to dangle across stuff. Oh my gosh, there's a plug, table, multi-plugs upon it. There's many of multi-plug item around the room. Yes, sir. Let me see am I anymore? Because I'm not entirely sure about that. My table's kind of covered in stuff. I will look. All right, because what we're trying to do is we're trying to switch this to log form from exponential form. That's not it. I have no idea where my extras got put. Oh, I think I got one. Nope. What can we do to switch this from exponential form to log form? Say it again. Our base is 4. You're right, I just physically could not hear you. So we're going to have our log that has a base of 4. What's our argument? Because that's this guy here. That's where we're getting this base from. We need our argument. That is not the color I tapped on. This guy is right here of 64. And that's going to equal what? 3. Here you go, Gia. I found it. So the bottom one just below it is going the other direction. We now have a logarithmic form and we want to switch it back to exponential. What do? What's our base? 3. It's this little guy down here. That's our base. What's our power? 2. This guy. And it's going to equal 9. This guy. So our BPA log BAP, this guy's really important. He plays a big part of this chapter. So our BPA log BAP is really important. You gotta have that. And honestly, this is a place where a lot of us got stuck just before we went on break. So this is a thing we really need to lock in on. Because we have 2 chapter tests between here and finals. We have 33 more school days. 33 school days.
It's like a month.
School days. Month and a half. Because there's 5 school days in a week. But yeah, no, it's... All right. Then let's look at this guy over here. We have a log. And we want to see if we can figure out what the heck this x is. But this x is inside the argument. And I don't want to have to deal with that because that's super gross. So what can we do from here? Maybe related to something we just did? Because we have a base. We have a power. We have an argument. So switch this into log or into exponential form. Rewrite this as our base of 2. with our power of 3 that equals the argument, this guy, x minus 1. So switch it around. If we have a log on one side, switch it back to exponential form. That makes it way easier because we're way more comfortable with logs when they look like this because it don't look like a log. How can we simplify this now? Yeah. 2 to the third is the same thing as 8 equals x minus 1. Then what? Plus 1 on both sides. So we're going to get that 9 equals x. Our last piece on here is to check it. If we substitute 9 in here, we need that our base is positive and our argument's positive. So if I substitute in a 9 here, our base is still a 2. Our argument, 9 minus 1, is still positive. So this checks and we are good to go. So this is our answer. It checks, and that's all. Okay. Questions on this one? Okay, because we're going to do kind of like a whirlwind review of the things we've already done in this chapter, because I know it's been a week since we mathed, for at least most of us, which is valid. Spring break is a time to recharge. Valid. But that means we're going to refresh the things we need to know because we got a chapter test coming up next week. So we need to know. So, why is it doing this? Let me do that. Okay. So what we're going to do is fix my screen because it's being a jerk. There we go. So we're going to be in your note packet. It's the second to last page. It doesn't actually have a page number on there, but it's the second to last page. I hope you do, because I don't have tons of them. What's up? No? Where's your pass? Just because they're on top of things today, because they're preparing for a little further this being our first day.
Yeah.
Fair, that would not be, nobody would be taking the job together. No, otherwise you would have done it yesterday. Morning or afternoon?
Yeah, this is where I stopped.
That's a little bit late.
Where we at?
I think falls into 40.
But like, I'm so confused.
16, so if we
Because I
can't.
this is
We're good, we're good at
it.
it. So it's 6.
It might come cleared up last night, so.
Yeah, nobody did.
So
All right, so we're gonna talk through our expanding and condensing again, real quick, just because we haven't done that in, again, like a week. So I've got a little kind of visual of it on the left-hand side. For those of us that have forgotten, we did write them out full steps with words on, I want to say it was page 6 and 7. Yeah, should be pages 6 and 7. So if you don't like this little pictograph thingy on the side, pages 6 and 7, and your little packet should have it in words. But what this is doing is this is showing us our relationship between, wrong thing. Laser pointer. Our division and subtraction that go together, our multiplication and addition that go together, and our powers and coefficients. That's what the P and C are. So if we're expanding, we're going to go from the top down and left to right. So our division becomes subtraction, Multiplication becomes addition, powers become coefficients. If we're condensing, we're going the other way. Coefficients become powers, addition becomes multiplication, subtraction becomes division. So whether we're trying to make it bigger or smaller shows us what we're doing here. So it's kind of just like a shorthand way of doing everything we did for like a week before break. So we're going to just do a couple on this page. There's nothing wrong with any of the other ones on here. I just didn't want to spend a ton of time on it because we have already done this. So if we're looking to condense number 2, which is number 2 on the page, what are we going to do first? Our coefficients. They need to go up and become powers. They need to become exponents. So our very first step is going to be to take our coefficients, like this 5 here, and put it up as a power on the x. And we need to take the 30 and put it up as a power on the y. So our first step when we're looking at condensing this is going to be writing it as log base 2 of, oh, well, that color disappeared. X to the 5th minus r log base 2 of that y to the 30th. So raising those coefficients up as powers. What can we do next? We are going to switch our subtraction to be division. Whenever we switch our addition to be multiplication or subtraction to be division, that's when we're going to start losing logs. The whole point of condensing is to get it down to one singular log. So we're going to write this as our log base 2, and we are going to divide our x to the 5th by the y to the 30. Those two pieces go together like that. And this guy is our answer. We know we're done when I have just one log and everything's after it. When we are condensing, I'm trying to get it all smushed together into one single problem. One single statement. Yes, my dear.
Why you change this 5 to 30?
From here to here,
Yeah.
that would be our coefficients that need to become powers. So the numbers out in front are multipliers, coefficients, whatever word you want to use. They go up and become powers. So that's why the 30 became a power of y and why the 5 went up onto the x. So we got it. Every coefficient goes up. Okay, good question. Number 6 is kind of the same thing, but in the opposite way. Number 6, we're trying to expand it. So now we're going to go the other way. I'm trying to get this to have as many pieces as possible. We're done when each log has only one thing after it. So we need to get this to be as big as we possibly can. So what are we going to do first on this guy? What is our first step going to be here? We have, whoa, not the pen I wanted. We have a division here. When we got this fraction, that means division. So our division needs to turn into subtraction. Whenever I do that, now since we're expanding, I'm going to get new logs. We're getting more logs here. So we're going to have our log base 6 of x cubed minus our log base 6 of y cubed. Yeah. We don't have any multiplying in here, so we're ready just to go straight into our powers. And our powers are going to come down and become multipliers. So for both of these powers are going to come down and become multipliers. So I can rewrite this as 3 log base 6 of x minus 3 log base 6 of y. And since each of our logarithms now has a single term after it, 3 log base 6 of x, minus 3 log base 6 of y. There's only one piece after the log. That means this guy is our fully expanded answer. That's expanded as far as it can go. Yeah, let me write your pass. Okay. You guys okay? Okay. So there's a lot of really good expanding and condensing practice on this page. I didn't want us to spend all of our time on that. Because I want us to look at this solving a bit, because that's going to come up a lot more. But the expanding and condensing is an important piece of what we're doing. So questions on this before I change it? Yes, sir. Mm-hmm. All right, we are going to do 2 more, just 2. It's on the very, very last page. We're going to do 6 and 7. I have no idea why I just crossed the L like it was a T. We're just going to call it good. They're not going to look that close. I was about to say, you're going to come see me instead of signing it. Woo, we'll get there. Woohoo! My brain's braining. I crossed the L like it was a T. I wrote it to me and then signed it as the restroom. Like, we just all over the place. It's all good. You good? All right, so take a look at this one. We are ideally hoping to solve this. If we had it as a single log, like the one in the bell work, that we could do. We can switch it between log form and exponential form. But we don't have just one log on this side. I've got 2 logs on this side, which makes it things a little bit grumpier. But we've done a lot of things since bell work. I wonder if any of those things we've already done can help us with this. If we would really, really, really like this to have just one single log here, is there a way that I can smush those 2 pieces together? What if we look at it without that part? It's not looking an awful lot like these guys. So what we're going to do is we're going to look at this side. We're going to see if we can condense it down to just one single log. I'm going to trip over that thing and it wound up exactly where it was. That's why I don't do sports. So what we're going to need to do is we're going to need to condense this a little bit. We really, really, really would like to have this thing have just one log on this side. So we're going to aim to condense this guy down. What can we do to condense this? What can we do to this to make those things squish together? We have subtraction. What does subtraction turn into? Division. So I can rewrite this as our log base 8 with our division that has our 4x squared divided by 2. So we can condense this side. Now I have a single log equal to a number. Now we're back to exactly what, that is not what I meant to do. Now we're back to exactly what this kind of guy was. So just like we did over here, how we took our logarithm and switch it to exponential, when we're over here, we can take our logarithm and switch it to be an exponential function. We're going to have our base of 8. What's our power? 1. And our argument is this guy, our 4x squared over 2. Can we simplify this? What's 8 to the first? Just 8. How about 4x squared over 2? Can we do anything with that? Yeah. These are both divisible by 2, so I can simplify this down to be just a 2. So this can be 2x squared. Does that help us see what we could do next? Divide by 2. Divide both sides by 2. That's going to give us that 4 equals x squared. We're almost there. If we square root both sides, what are we going to get as our solution? X equals 2. That's the next question. Or negative 2. We could have a positive 2 or we can have a negative 2. Whenever we square root both sides, we need to include the plus or minus because it could be that x equals 2 or it could be that x equals minus 2. We have to check both. We need to see if either one of these is going to cause problems. Here, we cannot have negative bases. We cannot have negative arguments. At this point, we still do not have the tools it takes to change the base, so we should be good there. But if I substitute in a 2 for the x up here, will our argument be positive or will our argument be negative? It'll be positive. So that one's good. If I substitute negative 2 in place of the x, is our argument going to be positive or is our argument going to be negative? It's also going to be positive. So this one also checks. We actually wound up with 2 answers here. Because if we put in negative 2 squared, that's positive 4. Like, it is what it is. So we're just going to have to be really careful with those things. Okay? So whenever we are solving logs, it's important that we are trying to get it to an exponential because that's going to be way easier to work with. And that we check. We need to have no negative bases, no negative arguments. We're going to do one more. That's it. Just one. We're going to do number 7, so it's the very next one. Very similar vibe. Very similar vibes. What should we do first here?
Treat the logs out. I'm not made all right, my bad.
More specific. Make it multiplication. We need to condense this again. I have addition here. Addition turns into multiplication. So we can condense this down and make this be log of our x plus 15 times x. That equals 2. Now what can we do? We're down to a single log, and our log equals a number. We could, I'm going to save it for the next step, though. I was like, you could distribute here, but I feel like it's easier if we wait a second. What's our base on this one? 10. So I know my base. My base is 10. We know our p. We know our argument. Switch it to exponential form. So the very first thing I'm going to do, and then I'll go and grab that distributor and go. So we're going to have our base of 10. This is using our log base b of a equals p, log BAP, and our BPA, that guy. So our base is 10, our power is 2, and it's going to equal that argument of x plus 15 times x. This is a lot easier to deal with than the stuff that has the log in them, because logs are scary and weird. Once we get it here, we can pretty much ignore the log stuff up above it, and we can just look at this stuff. And we can simplify some things here. What can we simplify in this step? What is 10 squared? 100. And then, I was like, I know we already said it, but we can also do this multiplication. We can do this distribution here, where we're going to have our x times x giving us x squared, and our 15 times x giving us 15x. What the heck do we do to solve something like that? Factor it. Whenever we are solving, we're trying to get down to an x equals. We could, quadratic formula, when we have an x squared, we could try and do something square rootsy like we did on the last one. But on this one, since we have this loose x, he's the one that throws the wrench in our plan to try and square root things, we do need to either factor or use a quadratic formula. I highly recommend trying factoring. What do I need to set this equal to first before I can factor stuff?
Subtract 100 on both sides.
We need to subtract 100 on both sides because it has to equal 0 before we do. So we've got to stop giggling so that we can try and do this with factoring. So we're going to have our x squared plus 15x minus 100. And we are going to try and factor this thing. I'm going to go through the whole factoring process on this, partly because it's good practice for us, partly because the next chapter that we do after this one, our last chapter of the year, has an absolute ton of factoring in it. A ton. So if factoring is something we struggle with, now is a great time to figure out where our sticking points are and try and find something that works for us. Not even kidding, there's going to be at least one problem where we have to factor 4 times in the same problem. There is a bunch of crunch of factoring in the next chapter. Lots of it. So let's practice it while we're here. This is when we take our A times C at the top, B goes at the bottom. Using our equation from down here. A is the number in front of our x squared. B is the number with the x. C is the number on the end with no letter. So we typically put our A times C at the top. That's our 1 and our minus 100. So we're looking for minus 100 at the top. And our B goes at the bottom. That's our 15. What that tells me is we're looking for a pair of numbers that multiplies to make negative 100 and adds to make 15. What numbers multiply to make 100 and add to make 15? Multiply to make negative 100. Yes. It's our pair of numbers that multiplies to make negative 100 and adds to be 15. If this is a place where you get stuck, your option, the way to figure this out, is to find our pair of numbers that multiplies to be 100. Since the top is negative, we're looking for the differences. Which pair of numbers has a difference of 15? We can figure out which one's which in a minute. But go through your list of factors. 1 plus 100 or 1 minus 100 is definitely not 15. 2 and 50, they have a difference of 48. 100 doesn't divide by 3, but we have 4 and 25. They have a difference of 21. It's getting closer. When we start looking at 5 and 20, that's where we can see that they have a difference of 15. And if I need it to multiply to be negative 100 and add to be a positive 15, that means my 5's got to be negative. So if that's a place that's not necessarily intuitive for you, that's a way to kind of work it through. If you do not like to use the box method, you do not have to. There are lots of options for you. Yes, my dear. Oh, this one right here? Because it doesn't have a base written up here, that means it's common log, and common log always has a base of 10. So if it says the word log and it does not have a number, it's a 10. So when we're filling in our box to do the factoring part, we're going to take our x squared from the equation, it's this guy, and the minus 100 from the equation. It is neither of the purple numbers in the x frame, neither of them. The pieces we get out of the x frame are those 2 blue numbers, and they get this letter. So we're going to have our minus 5x and our positive 20x. Again, if you do not like the box method, that is totally valid and totally fine. There are lots of options for you. I don't care how you factor, just that you factor. And if you do it in a weird way, you might have to explain it to me a couple of times so I know what the heck is happening on your paper. So as long as you can explain it to me, we're good to go. pulling our factors in columns and rows, what are we going to have? What is shared between x squared and 20x? X. What is shared between minus 5x and minus 100? Minus 5. What is shared between x squared and minus 5x? And between 20 and minus 100? 20. So our factored form of this equation, we get our x minus 5 and our x plus 20. And we're almost there. Like 2 steps left, and that'll be it. Because we have factored form, which is super duper awesome, but we don't need factored form. What I need is solutions. Roots. Zeros. Set each of those suckers equal to 0. X minus 5 equals 0. X plus 20 equals 0. What do we get as our 2 possible options for x? X could be 5, and x could be negative 20. Those are our pieces. Now we have to check them. Yes, we have to check them. Yes, you have to check every time. If I substitute in 5 here, my base, we don't have the tool to change it yet, so we're good there. Is my argument positive or negative for the 5? Positive, because 5 plus 15 is positive. And if I substitute a positive 5 here, my argument is positive because it's a positive 5. So positive 5 definitely checks. What if we substitute in negative 20? It don't check. It doesn't check here. It doesn't check here. This fails and fails hard. Because negative 20 is definitely not a positive argument. So, oh my gosh, they made us do so much work and it doesn't even count. Oh my gosh, they're so extra. This is not a valid solution. It is extraneous. It's so extra. So this is not a valid solution. X equals negative 20 is not a solution. Our only actual solution here is the x equals 5. We only have one answer. So on these kinds of problems, we can get one answer, we can get 2 answers, we can get no answers. That's entirely possible. Lots of options. Again, the rest of the ones on this page, they're not bad. I just didn't want it to take a ton of time to work on them. And I just kind of picked ones that were kind of relatively near each other that did what I wanted them to do. So tomorrow we will go back way earlier in the packet to page 10. So we're going to go from 17 to 10. I just needed to kind of refresh us without just instantly shoving us back into the world of new. So everything we did today was a review. Just kind of oozing us back in because I know that going back to school after break is very much like that. For us too. Okay, so homework 8.3 you guys should have. That's the one that you guys got right before break. So if you still need a little time to finish it up, you got some time. We've got almost 10 minutes left. And tomorrow we will do pages 10 and 11. Oh, snap. Boop.